Hello and welcome back to my channel, students. In this video, we will be discussing questions which were asked on 29th of January 2024 JEE Mains. The chapter is Laws of Motion and Work Energy Power. Students, as you know, that in almost all my videos, I try to show you how you save the time in the exam hall and how you calculate it actually, because I have been showing all the calculations actually how I do and how it has to be done in the exam hall also. The idea is to ensure that you are able to solve all the 25 questions in 1 hour. Okay, students. So on an average, you are able to solve 25 questions in 60 minutes. So you are required to not use more than 2 minutes on an average, so that if you are able to save time, you can invest that saved time in some other more difficult and more lengthy questions. So on an average, you should be able to solve within 2 minutes. And let me tell you, students, frankly speaking, a lot of questions are there which can be handled, which can be solved within 1 minute. You don't even require 2 minutes. You can easily solve it within 1 minute also. But of course, certain questions might require more than 2 minutes. So naturally, you have to balance them, isn't it? So wherever you are able to solve the question within 2 minutes, whatever time you save, you are supposed to invest that time in so-called lengthy questions. Okay, questions which take more time to solve. Right, and here and there I keep telling you the shortcuts and also the way you are supposed to solve it. Okay, students. So please follow my channels rigorously and attentively and try to extract the maximum benefit as much as possible. Right. So moving on to question number 7. Block of mass 100 kg slides over a distance of 10 meters on a horizontal surface. If the coefficient of friction between the surfaces is 0.4, then the work done against friction is. This is a very simple question, students. As we know that if a block is placed on a horizontal surface, rough horizontal surface, okay, and if it is moved by a distance 10 meter, then work done, we can freely write the formula, work done by a constant force. So work done by a constant force is this. Sorry. Okay, students. Then they're clearly asking work done against friction. So whenever you calculate work done against a force, you put a minus sign. Okay, students. There are two types of formulas for work done. One is work done by a force and other is work done against a force. So mostly we use formulas for work done by a force, which is Fs, vector F dot vector S. But in case if you are asked to find the work against a force, you have to use the formula this. So Fr is friction here. Now if movement is in this direction, let us say S, then definitely friction will be in this direction. And since movement is taking place, so the friction will be equal to limiting friction, and limiting friction is equal to mu into n. If you draw the free body diagram, students, you will get this vertical forces, only two vertical forces will be there. And of course, since the movement is horizontal, the vertical forces must balance each other. So therefore, normal reaction will be equal to mg. So this is how you write. So mu into mg is the force of friction. If you remember, then directly you can write this. And displacement is 10 meters. Okay, then cos of 180 degree, you can see displacement is in this direction, frictional force is in this direction. You can see angle between them is 180, cos 180 is minus 1. So minus into minus becomes plus. So mu is given as 0.4. Students, see, instead of 0.4, try to write like this, 4 by 10. These are small tips which will save a lot of time, and at the same time they'll save you from committing any mistake. Mostly students commit mistakes in handling the decimals and all. So just get rid of decimal. Instead of decimal, write it as a fraction. A very small but important rule. That mass is 100 kg. So 100 kg. I am writing all the quantities in SI unit. So I don't have to write the unit. Okay, students. Unit is understood here. So kindly, I am trying to avoid confusion by not writing the unit. So we have 4000. So third option is the correct answer. We'll go with the third option. Moving on to the next question, question number 8. if the radius of curvature of the path of two particles of same mass are in the ratio 3:4, then in order to have the centripetal force, same centripetal force, their velocities. So you can see mass is same and velocity, is centripetal force is also same. Now see how to solve these kind of questions, students. See, whenever you have to find the ratio problem, just write down the formula which interrelates all those things. Radius of curvature should be involved, mass should be involved, centripetal force should be involved, and velocity should be involved. So the only formula which comes to our mind is centripetal force is mv square by r. Okay, students, this is the first step. Then the second step is mark the quantities which are same. So here centripetal force is same, mass is same. That means what? V square by r is constant. Okay. Now since we require V, so straight away you can write V is proportional to R, root R. So immediately we get this relation. From this relation it's very easy to solve. So we have V1 by V2 is equal to under root R1 by R2. So R1 is 3 and R2 is 4. So we have root 3 is to 2. So this should not take more than 1 minute. Perhaps somewhere around 30 seconds, not more than that. Then moving on to question number 9. The potential energy function in joule of a particle in region of space is given by this. Here x, y, z, the magnitude of x component. As you know, students, in case of a conservative force, the x component is given by the partial derivative of potential energy with respect to x. Negative of partial derivative of potential energy with respect to x. So if I differentiate this with respect to x, I am going to get only 4x, that's all. Because y will be a constant and even z will also be a constant. So this is the x component. This is the x component of force. Just put x equal to 1, that's all. So the required force will be minus 4. Since all are in SI unit, so you get Newton. So they are asking the magnitude. So we'll go with the third option, 4. You have to drop the minus sign if they are asking the magnitude. Then moving on to question number 10. A stone of mass 900 kg is tied to a string and moved in a vertical circle of radius 1 meter, making 10 rotations per minute. The tension in the string when the stone is at the lowest point. So when the stone is at the lowest point, students, you have to find the tension in the string. Suppose its angular velocity is, at that instant angular velocity is omega. Then we can write, as per law of circular dynamics, net force towards the center must be equal to centripetal force. So therefore T equal to mg plus m omega square. So we can take m common. So G is 9.8 given, omega square. Let us find omega, students, here. So omega is 2 pi f. Frequency is 10 rotations per minute. So 2 pi 10 rotations per minute. So 1 minute has 60 seconds. So this way you calculate this in radian per second. So this is pi by 3. So pi square by 9 into radius. Radius is 1. Mass is 900 gram. So to gram to be converted into kg, divide by 1000. Then you have 9.8 plus 9.8 by 9. So take 9.8 common, students. So when you take 9.8 common, we will be left with 1 plus 1 by 9. So it will be 10 by 9. So as you can see, that 9 gets cancelled, 10 gets cancelled, and finally we are left with 9.8. Okay, so 9.8 Newton. Will go with the second option. Then moving on to the question number 11. The bob of a pendulum was released from a horizontal position. The length of the pendulum is 10 meters. It dissipates 10% of its initial energy against air resistance. The speed with which the bob arrives at the lowest point. So let us draw a rough diagram, students. As you can see, the bob is released with the string in the horizontal position. Okay. So this is the length of the string. As we know that it dissipates 10% of its initial energy. So taking this as the datum level, we can write that the kinetic energy is equal to gain in kinetic energy is equal to loss in gravitational potential energy. So potential energy lost is mgh, h is L. However, it is clearly given that the entire potential energy lost doesn't get converted into kinetic energy. Only 90% of it gets converted because 10% gets dissipated. So we have 90% of this gets converted into kinetic energy. So mm gets cancelled. So we have v square is equal to 2 gl into 9 by 10. So 2 g is 10. Length is also 10 meters. So 9 by 10. So 110 gets cancelled. So this can written as 10 can written as 2 into 5 and this is 9. So V will be square root of 4 is 2, square root of 9 is 3 and square root of 5 is 5. So we have 6 root 5 meters per second. We'll go with the first option, students. Moving on to the next question, question 12. A bob of mass m is suspended by a light string of length L. It is imparted a minimum horizontal velocity at the lowest point A such that it just completes half circle reaching the topmost position. The diagram will be something like this. Okay. The ratio of kinetic energy at A to that of B. This is the center of the circle. So L is the what we call radius, which is this. Now, if you have done a few problems based on this, you must be knowing that the imparted velocity has to be root 5 gl, so that it is able to successfully negotiate the circular path, and at the highest position the velocity, if you apply law of conservation of energy, you will get root gl. Okay. In fact, when you apply the law of circular dynamics here, taking tension to be 0, you will get this. Based on this, you get u mean equal to this. Okay, students. So therefore, now kinetic energy at A divided by kinetic energy at B will be velocity square at A upon velocity square at B. So this is 5 gl, this is only gl, so you have 5 is to 1. So we'll go with the second option, students. Okay, that's all in this video, students. Thank you so much for watching my channel. Kindly subscribe to my channel and hit the like button.